your textbooks, page 344. We're talking about curves of best fit. The goal is to construct and interpret a curve of best fit. So previously to today, we've talked a lot about a line of best fit. Okay, so we're going to address this question up here, curve of best fit or line of best fit in a minute. But it's important that you make that distinction between the two, because there are significant differences, and there's differences in the process in the way you need to answer. Okay, one of them being, unfortunately, is we don't really have much of an algebraic option when we go to curves of best fit. Okay, that's a predominant difference. All right, whereas last lesson I was showing you two options, one using the graph and another one using algebraically solving for the slope. In this particular case, I'm going to show you in a minute, we can't use that method. So we have this this question here. It's talking about a pendulum. It's on page 344. So what they're measuring is, when we talk about period, it's just the amount of time that it takes for it to swing from one side to the other. Okay, a period is the amount of time in a cycle to go from one point back to that same point. All right. So what they're wondering is the length of the rope that they used. You guys all know what a pendulum is? It's like a ball on a rope that swings back and forth. So they're wondering, does this length matter, or does it make a difference in terms of the period, or the amount of time it takes to move from one side to the other? Okay, one of the students says it does, the other one says I'm not sure. So what they do is they try a whole bunch of different lengths. This is 0.1 of a meter. Okay, so that means that this is 10 centimeters, all the way up to 100 centimeters. Okay, to give you an idea of the size of the ropes they're testing, which is pretty realistic, right? They can do that. And then they're using a stopwatch and they're measuring the time in seconds. So the first thing you guys all need to get in the habit of doing with all of these problems, before you even see this, okay, I know it's up there now, so you're tempted to look at it, but you got to get in the habit of looking at this and kind of quickly scanning the numbers to see if there's kind of any sort of consistent pattern and any sort of outliers. Okay, that goes for the last section in 6.2 and for this section. So here we can see this number is increasing every time by 0.1. So that is our what? Independent or dependent? Yeah. Dependent. Independent. Yes. Okay. Good. Because that's again because they're choosing the length of rope and they're measuring the time. Okay. So those should be pretty easy distinguishable. And then we're increasing right here by 0.1 every time. And then our period, we can see it's 0.64. It's going up, going up, going up, going up, going up. It actually goes up every single time. So it's a straight kind of pattern in a sense. I said straight pattern, but it's actually not a straight pattern. Okay, and that's what we're looking at. So when we graph it, we get a graph that looks like this. For an accurate graph, you're going to look at page 344 and 345. They've actually graphed this 3 times. Okay? It takes a long time for me to graph extremely accurately, so I'm just going to give you a general idea on the board, and we're going to go from there. So if you only had been educated in the last section, which was the line of best fit, you might be very tempted to draw a line straight through here like this. Okay? And this data, I got to tell you, is difficult not to want to draw that line. Okay, even for me, looking at this, it looks almost like a linear pattern. Okay, it's not that pronounced, the fact that it's not linear. Okay, however, if they were to extend this rope of the line, what they would find is that it's not linear at all. What happens now is that as the extension of the line continues, the period doesn't increase much more. So we get this pattern of this line that looks like this. Okay? And that's what's called the curve of best fit. Okay? So, you're going to have to be very careful when you guys go and try and decide or draw, whether it be a line of best fit or curve of best fit, to really observe this pattern. Is it leveling out? Okay? Because it is tempting, as I said, to draw a line straight through here. The difference is that this pattern, as you can see, all of these values are very similar. So you can see that this slope is flattening out. Okay? Matthew?
How do we know whether to draw a line of best fit or a curve of best fit?
Right, you have to observe the data. First and foremost, you need to accurately graph it so you can see, and then it's a judgment call, right? Hopefully the question will be clear enough and the data will be clear enough where it's pretty evident, okay? This one I said is a little bit difficult, but In the other example, it is quite evident. Okay, yeah.
So sir, if you saw that graph somewhere and they asked you to draw a line of best fit or a curve of best fit, would you draw a line or a curve?
I would have drew a curve. Okay, but again, not looking at the one I drew on the board, looking at the one in the textbook. I guess they're both pretty similar, but yeah, it's tough to say. This is a really tough example. When we see the next example of the sheet, it's a little clearer. Okay, and in actual reality, guys, what I would have done if I got this is I would have took more data points, just to see what's actually more. It'd be great to see one more data point at 2 meters of length, right? Which would be out here, and then that would give us a really good idea. If it was here, we'd know it would be a curve. If it was way up here, we know it would be linear. You guys understand that?
Yeah. Well, it wouldn't be exactly linear.
No, it would be a linear pattern though.
Yeah.
Okay, and it would be a line of best fit. So that gets into the question: curve of best fit or line of best fit? All right, I think we've kind of answered that so far. Is that you need to decide. So decide based on accurately sketched scatter plot. Now, if you're running the experiment, you maybe take more data points. Maybe take more data points towards end of graph. Okay. So if there's a communication on the test, a communication question, I say, how do you know when to draw a curve of best fit or a line of best fit? This is what you'd say, right? You'd base it on how the data looks. Yeah.
So you can't use an equation just to find out, like we did in the last one?
No. And the reason why is, right, if I take 2 points on here, right, if this is my curve of best fit, right,
Yeah.
and I take 2 points on here, let's say I choose this point and this point, okay, which is reasonable, they're a fair distance apart, they both seem in line with the pattern, you're definitely going to conclude that, you're making the assumption that obviously when you're taking 2 points that it's a linear pattern. And now if we want to predict this length out here, what is the 2 meter length? Look at the difference we're going to get. Okay, so that's the reason why you can't use algebraic solutions for curves of best fit. Okay, and we don't quite yet have, well, we don't until grade 10, we don't have the mathematics to figure out the formula for curves. Okay, but you will next year. Yeah. All right, next question. What is the period when the length is 0.38 meters? So if this last point here is 1, this is 1, so right in the middle is 0.5. There's 2 points between 0.38, there's 0.3 and 0.4. It's getting a little messy here because this graph is not drawn very well. Okay? But just to give you an idea, the question reads, what is the period when the length is 0.38 meters? So what we need to do then, we don't have a point at 0.38, but because we've drawn this line of best fit, this curve of best fit, we have this point down here and we have this point up here. How are we going to find 0.38? We're going to go to 0.38, we're going to go up, and where it hits the curve of best fit, just like we did with the line of best fit. And then from that point, we're going to go parallel to the x-axis back to the y-axis. Okay, and that's going to be our value. All right? Any questions with that? What's that called? Michael?
Interpolate.
Sorry?
Interpolate?
Yes, interpolating.
Oh.
Good, very good. Yeah, so what is this process called? It's called interpolating. And the last question here, Sullivan, is there only one curve of best fit? No, why not?
Because we use other points on the graph.
Yeah, you could use other points, but not so much that. You're going to use the same points, really. I mean, the only reason that there's not only one is because, you know, Daniel might come up here and he said, well, I think the curve of best fit looks like that. Okay? So, just for that reason, you know, maybe human error, just human differences, just like there wasn't only one line of best fit, there's not going to be an exact curve of best fit. If anything, it's even more rough than the line was. Okay, because you're kind of guessing on this curve at the end, especially with these data points. This curve is kind of up for estimation. Yeah, Matthew.
Interpolating and extrapolating be a possible communication question on the test?
Yes, that was asked yesterday.
Oh.
This process here, where I found this point up here, I used 2 meters and I moved up. This is called. Yeah. Yeah, extrapolating. Extrapolating. All right, moving on to example 2. All right, this example says to help protect the environment, the steel factory is thinking about setting new standards for its carbon dioxide emissions. By 2012, the factory wants to emit less than 70 tons of CO2 per year. If it does not change its practices, is the goal realistic? So we have our measure of CO2 in particular year. So again, before we get to anything else, you want to look at this and tell us, you know, what is the pattern? What's happening here? So you really want to see that this value is going down, okay, every year. So this relationship is called what? This particular relationship.
Decreasing?
Nope. There's a name for it. We talked about it yesterday. When we have a pattern where the independent variable is time. Josh.
Trend.
Yes, good. This is called a trend. Okay, when we have our independent variable as time and we're tracking some amount of data, that's called a trend. Okay, because as the years increase, the CO2 is coming down, so that's considered a trend. Again, this question, if you look on page 346, it's a little bit more like this, the actual graph. Okay, there's that little kind of curve at the end. It's not much though, so it is, again, it's kind of a tricky question to make that assumption, again, that this is a curve of best fit as opposed to a line of best fit.
So it doesn't look a little more like a line?
It does. It almost looks like a straight line, but in this particular case, I would say the biggest hint on this case is the actual question. The question reading, you know, that they're decreasing their emissions per year.
So this decreasing, you know it's a slope, it's a curve?
Well, no, not necessarily. So it doesn't really tell you that it's necessarily a curve, but you just really got to look at the data points and try to make that estimate. Okay? But again, I can't tell you that that's an easy call to make, that it's not a line, because it is tempting to draw a line straight through there.
So it looks like the one that's curved looks like just an outlier.
Yeah.
So you could just put the line through.
Yeah, exactly. The only thing I can say is that I will try and make it clear on the test which one I'm looking for. Okay, so that it is clear. Yeah.
So you also would know, like, you would know that it's not a line, because, like, realistically, the carbon dioxide or monoxide, it wouldn't reach zero that quickly.
Yes and no, depending on what technologies they adopted, right? It could. You're right in the sense where it couldn't go below zero, so we know the line would have to end there, because you're not going to have less than zero emissions, right? However, you can't say that they can't change their technology and have the emissions keep decreasing, right? Good. Yeah.
Would you ever give us data and then ask if we should use curve line of?
Yeah, I could. Yeah, I could, but I would give you more clear data than this. Okay? All right, so the question reads, by 2012, is it realistic that this company will be below 70? If here's 2006, which was our last data point, which was somewhere around there, 100, we can see by 2012, if we're to extrapolate this line, we can see that it's not going to get as low as 70. If I run this back, it's close, but I think it'd be closer to around 75, 80. Okay? So I would say, for this particular question, no, it's not realistic. Don't pack up yet. Hold on, let me get this last question in so we don't need a two-part video. Alright, two-part video.
Oh yeah.